All right, hey everyone. So this is essentially the walkthrough for Lab 6. Now, I didn't ever get the live videos from CSU for what they've done there. So what I've done is I've kind of like other labs that I've done this semester. I've went in and uploaded um, experiments from YouTube that are very similar to what we do in our labs. So these might not be exactly the same experiments that are in your PDF guide here. So the PDF guide is available in Chem 21 as well, but it shows you exactly the procedures that we do for this lab that CSU will do in person labs. And if you want to look up these exact reactions, you can probably do that on YouTube. I saw a lot, there's hundreds, if not, thousands of these experiments very similar to this being conducted all across the world. So you'll see a bunch of videos. I've chosen three that I think are the most concise and applicable for what we're doing. So, but if you want to explore a little further, get a more in-depth video, by all means, you can do that. But these should address the general knowledge that you want to get out of this lab. Okay, so I'll kind of talk about that and also go to Chem 21 because I want you to know what you need to report. Let's do that first before we get into the nuts and bolts of uh, reaction rates. All right. So when you go to Chem 21, you have Part A, the effect of temperature on the rate of reaction. Part B, effect of concentration. And Part C, effect of a catalyst on the reaction rate. So for these three sections, I'm going to allow you to use whatever information you get from YouTube. Okay, so if you watch the videos I provided, I think the effect of concentration is well, he does different concentrations, not different volumes. So that might not be as applicable. What I'm saying is, I'll pretty much accept anything for those three sections. Now, you still need to um, be able to answer the post lab questions, okay? These post lab questions you should be able to answer based on your knowledge about what does the temperature do to the rate of reaction? What does adding a catalyst do to the rate of reaction? And what does changing the concentration do to the rate of reaction? All right. So, like I said, this is going to be a short and easy week. I won't say it's a gimme, but I mean, parts A, B, and C, I'm not going to grade very carefully, if at all. I'll probably just give it to you. I would like to see you answer things in, like, don't even pay attention to these. These are just, I just wanted to see if it would accept anything, and it did. So I've adjusted the tolerance where you can put anything in here. Okay. So for like a cold temperature, tube C is for cold, tube RT is for room temperature, so that would be about 21.0 degrees. Cold, let's say, would be 5.0 degrees. And then the time that it takes is the reaction time, right? So when we talk about heat and the effect of the heat on reaction rates, increasing the temperature increases the movement of the molecules. Okay, so we discussed this in my lecture course. If you haven't got there, as I made an announcement, I've extended all the due dates to November 28th. So you can kind of wait till you hit this section if you don't feel comfortable about it. But this lab is fairly easy. Okay, there's only three things you need to remember. Increasing the temperature will increase the reaction rate. Why is that? Let me come to me. Because the molecules are bouncing around so fast. Okay? Remember that temperature, if you hadn't learned this yet, you will. Temperature is a measurement of the kinetic energy of the molecules. Okay? However fast they're moving is how high the temperature is. Okay? The higher the temperature, the more they move. So, in a reaction where things need to move into each other bounce into each other or collide or whatever it is, then if I have an increased temperature, I increase the likelihood that that'll happen. They're bouncing a lot faster, so it's easier to bang into each other. Okay. Um, Now let's talk about concentration. Concentration, as concentration of the reactants increase, the reaction rate will also increase. Okay. Now this goes back to kind of Le Chatelier's principle. That's another thing that we learned in chapter 6. All right, let me pull up the lab guide because I believe they show the equation here. All right, so this is, make sure y'all can see this. Let me see if I can blow it up a little. Um, oh, that took you to a different page. Never mind. Sorry, I keep doing that and it keeps opening up another page instead of letting me mess with this. All right, so Le Chatelier's principle, and I might add a video to your lab Cougar View as well about this. It's just a sense of balance. Okay, when you add something to one side, it shifts the equilibrium to the other side. All right, so when I increase the concentration of, say, thiosulfate, sodium thiosulfate, which is Na2S2O3 right here, then I increase the reaction rate. Okay, Le Chatelier's principle says that if I increase the number of things I have on this side, it'll push, kind of like adding water to two different tubs that are connected. Right? If I add water on this left tub, it'll kind of push through the pipe and the water will balance. All right, so that's essentially what's happening here with a reaction. If I increase the concentration of the left side, it will push everything through to the right, increasing the rate of reaction. If I added something on the right side, it would push back to the left and decrease the rate of reaction. All right. So that's kind of how that principle works. I'll put in a good video that kind of explains the balancing of reaction rates, but most typically increasing the concentration will increase the reaction rate. All right. Now let's go to the third section, which is the effect of a catalyst on the rate of reaction. Excuse me. A catalyst is something that we put in there to increase the rate of reaction as well. Now it can do that in several different ways. Let me go back to this PDF lab guide. All right, this is what we call an energy diagram. All right, and so it's essentially like a hill. I imagine a guy pushing a boulder up a hill. We've talked about this in my lecture, but I'll do another quick one for the lab. Um, a guy is pushing a boulder up the hill, okay? And he has to get it all the way to the top of the hill right here to get the reaction to occur. Okay? He has to put so much energy into it before the reaction actually starts to occur. Okay? Now, what a catalyst does is it kind of knocks the top off of that hill. It makes it where he has to put a lot less work to get it over that hump. All right? So we say it in a few different ways. It lowers the activation energy. This little hump here we call the activation energy. It lowers that and allows the reaction to go faster. Um, and it can do this in several different ways. Sometimes it'll hold the atom in a certain way so that they can connect more easily. Sometimes it will give out electrons so that it can facilitate a reaction. There's all different kind of ways that this can happen. Um, but the most notable thing to take away from this is catalysts increase rates of reaction. For the human body, they're called enzymes, and it's essentially the reason our body can do these reactions so fast. If we didn't have the enzymes in our body to help facilitate these reactions, they would take years that we don't have to turn oxygen into energy or to get rid of hazardous materials, right? We break down these hazardous materials and get rid of them in these different ways, but it requires these enzymes, these catalysts to facilitate reactions. So that's just the three takeaways from this lab. Like I said, I'm going to be real lenient on the grading for this, but I would like to see that you know what you're talking about. Okay, so get in there and watch the videos. For those of you who haven't got there in lecture yet, uh, you can wait if you want to. I feel pretty confident that you can that this is uh, easier than most labs, especially the post lab questions. Like I've essentially just walked through what each of these things do for a reaction. But if you have any more trouble, like I said, you can go on to YouTube. Now these videos that I posted in your Cougar View are just the lab experiments, right? If you want to look up what now for my lecture course, I've provided a lot of videos such as what I'm about to mention. But if you want access to those, let me know. I can share them with you. Uh, but what is a catalyst? What is how does the concentration affect rate of reaction? I'm trying to look at your text and see. So I'm in the text right here. This is 6.4. It talks about how concentration reacts, how concentration affects reaction rate. There's the catalyst section. This talks about enzymes in the human body. So all of these things are materials you can use to kind of figure this lab out. All right. So that's it. Good luck, everyone. Like I said, the due dates are extended, so take your time with this if you need to. If you need any help, you can email me always, and I will see y'all next time. Bye.